Okay, so in today's tutorial, what we're going to do is we're going to recreate this tank game. And it is going to be 2-player, as you see right here. And it's going to be slightly different in what we've done before, because we're going to be dealing with non-axis aligned rectangles, which means that we're normally used to dealing with rectangles that are aligned with the axis. Okay, so either the y or the the y and the x-axis. So they are parallel to those. Okay, so the one side would be parallel to the x, one side would be parallel to the y, and so they don't rotate. Okay, so that's basically what we're saying. However, what we want to do is we want to rotate our tanks and have collision detection, so that if we were to shoot right beside the tank, and I'll show you, then we do not get collision there. So there we shot right beside the tank, there we shot right beside the tank. If I adjust it a little bit more, okay, and so that's because we're doing non-axis aligned collision detection. So that's great. Adds a little bit more complexity to your games, but it's not that big of a deal. We'll look at that and how to achieve that within this tutorial. Now, this is 2-player in that it's 2-player that is shared with one keyboard. So this is kind of an old school, kind of like 2-player. Later on, I will actually extend this as a web service, so that the truth will be on the actual game server, and the actual client will just be drawing what is from the server. Okay, so the server is going to be relaying all the positions of the bullets and the players, and so each cycle you'll get a new update. And so when an explosion happens, it's not calculated client side, it's calculated server side, and it would then be transmitted back to the players that a collision has happened. Now, there are different ways of doing that, some optimizations and so forth, and we'll talk about that once we get into the online 2-player mode of this game. But let's dive into this game right here, and let's see how you can achieve this and start applying this technique, especially with the collision, to your games. Okay, so in your file, what you're going to get is this is you're going to get a file that's basically going to look like this. Okay, and so this is the standard canvas starter file that I like to start with when I'm creating JavaScript games. And so I'm just going to go ahead and save as, and so we're going to save this into the tanks. Now, I don't care what you name it, but it does need to be saved as a HTML file, and I'll just put the extension .html. Okay, now we get our nice formatting there. Okay, so the first thing we want to do is we want to draw those tanks, and we want to draw them rotated as we turn. Okay, so in the source file on GitHub, in that repository, you'll find the tank images that I'll be using. So we're just going to say let tank1 equal new image, and then we're going to say tank1.src is equal to .png. Okay, and so tank2 is pretty much the exact same thing. So I'm just going to go ahead and copy that, paste it, and we'll just change these 1s to 2s. Okay, so to draw our tank, we're actually going to need our controls. Now, you started out with the event listener, but it doesn't really, we need to implement this function in order for this to happen, okay? And so we're just going to go and implement key down and key up handlers right here. But in order for those key up and key down handlers to work, we're going to define some variables. Okay, so the first variable is or all the variables are going to be the keys that we're pressing. So here we're just going to say let up pressed equal false. Probably pretty. I'm going to go ahead and fix it. I normally have my keyboard on a soft surface. Okay, so we have left press, and then of course right pressed, and then we're going to have our 0 pressed, and this is going to be the firing for the left up, down, left, right buttons. And so we're just going to say let 0 pressed. Okay, and then the other controls are going to be WASD, and then A pressed. Okay, and so now we have our controls, and from there we can go ahead and make our key down handler. So let's go ahead. I'm going to let's go ahead and put this in here real quick. So we're going to say, so function key down handler. The heater had to pop on, didn't it? Let's see here. Okay, and so now we're just going to do our key down handler. So here we're just going to say and this is going to take in the event E. And this should be pretty standard if you've seen any of my videos. And this key down handler is standard as well. So we're just going to say, just going to say this. Okay, and so this is going to be, if the key code is 38, we're going to say up press is true. And then here, and then if it's 32, that's going to be space pressed. Oops. Go ahead and do that. And then now we just need to do the WASD keys. And so here we're going to So all that fits on one line, or within one screen there. And so here we have player 1, which is this player right here, and then player 2, which is right here. So if you need to, go ahead and pause, and we need to get this Keydown handler situated. So just go ahead and put the values that I have here. And then what we're going to do is do the key up handler. So you can essentially just copy this one and we're just going to change the name to key up, and here we're just going to find and replace trues, find false, and find trues and make them false. Okay, so here we will, so basically this is when the key has been released, we're going to set it equal to false. Okay, and so now what we want to do is define what a player is. And so here you can just pause and go ahead and get that down. And I'm going to go ahead and hide these from now on. We'll come back and we'll need to adjust this in just a second. But for right now, give me some little space to work with here so that you're in the center of the screen or towards the top. We're going to define a player. So here we're just going to say function player, and the player is going to have a few properties that it's going to start with. It's going to have an X, a Y, a rotation, which we'll call rot, a W, which is a width, and a height. Okay. Now, here we're just going to define the actual properties of the player. So these are just the parameters being passed in, and the player has no way of storing these until we tell it how to. And so here we'll just say this.x is equal to the x being passed in. So this.y, which is the property of player, is equal to the y being passed in. This.rotation is equal to the rotation being passed in. Okay, and so there's a few other things that we probably want to define here, and so this.canFire, and we'll just start that off as true. This.score, and then this.hasBeenHit. And so those are things that are going to start off as either true or false. Okay, so this defines like the framework of a player, and so now we just need to actually define the players. And so here we're just going to say let player 1 equal to new player, and we need to give it some parameters to pass in. Well, we're going to let its x be 50, 100. The rotation is going to start off as 0, 40, and 30 for the height. I'm just going to go ahead and copy this because player 2 is very similar. And it's going to start out at 400, and then 400, and the other properties are the same. Okay, and so now what we want to do is go ahead and maybe draw our player. Okay, and so I usually use a different draw method here, but this one is from an old game that I had laying around that I've been meaning to make a tutorial out of for a few years now, and so I'm finally getting to it. And so I never actually changed the way I do the draw function. So if you've seen some of my newer videos, that's how I do it now. But we'll just stick to the old way of, to the way that is in this actual game. Okay, so I'm not going to change up any game or any game code on the while doing the video. So here we're just going to do clear rect I'm sorry, we have to do ctx.clear rect, and we're just going to clear the whole screen. Okay, put a space there. And then, so now what we want to do is we want to draw the player, and I could probably pull this out into its own function, but what we have here is fine. Okay, so if we're drawing an axis aligned image, then we could just say draw image, but we're not doing that. So we need some actual code to actually rotate the image. And so I'm going to go ahead and we're going to go ahead and create that function real quick. All right, so up here, now I've used this draw image rotation rotated function so many times, I've kind of forgotten where I got it from. So if the code, it may be from Stack Overflow or whatever. But you know, whatever. That's how code goes sometimes. You've done it so many times. The first time you may have credited the source, but after it just becomes, you know, cemented in your brain, you just kind of no longer, you know, it's been so long you wouldn't even be able to okay, so we're going to be passing into this rotated image function the image being drawn, the X, the Y, the width, the height, and the degree of turn. Now there's two things here. The degree of turn, I usually think of a degree not in radians, but so on between 0 and 360 instead of 0 and 2 times math.pi. Okay, but you know, they're very similar. I mean, easily interchangeable. But since I do think of it as between 0 and 360, we're going to create, we're going to convert our degrees into radians. And so here, we're just going to say let radians equal degree times math.pi divided by 180. And so that's just the formula to convert degrees into radians. All right. And so now we're going to be doing some weird stuff. We're going to actually translate or call the translate function, which is going to set the origin to the center of our image. Okay, so the origin of the canvas. And so that's the center of the canvas is going to be located at the center, or the origin of the canvas, which we are going to rotate around, is going to be set to the center of our image. So when we rotate it, the whole world is rotating around our image. Okay. And so here, we're just going to do ctx.translate, and this is going to be x plus width divided by 2, y plus height divided by 2. Okay, I'll normally do that. And then here we're going to rotate it. And so the rotation function takes in radians, and so that's why we had to convert it. And so here we're just going to do a ctx.rotate, and we're going to pass in that radians value that we calculated. And then we're going to do our draw image that we're used to doing. So this is going to be ctx.drawImage, and it's going to take in the image, the width divided by 2, and then times -1, the height divided by 2 times -1, and the width and the height. Okay, And so here, what we're going to do is we're going to reset the canvas. So we've already rotated the canvas. We've drawn our image, and now we reset the canvas so that our image is now rotated in respect to the canvas. Okay, so here we're just going to do ctx dot rotate, and this is going to be radians times -1. And then we're going to translate it back. So here, x plus width divided by 2 times -1. And then this is going to be height. Okay, I can just go ahead and copy this because it's pretty much the same. Y height divided by 2 times -1. Okay, so this is our image. This is to rotate the image, and I'm just going to take this D out. That is a typo. So draw image rotated rot, and so this looks good. And so now I'm just going to use that function when I am going to draw my players. And so here inside our draw function, I am going to have an if statement that says if the player has not been hit, we're going to draw it. So we're going to say draw image rotated. Remember, it's going to take in all those things. So we're going to say tank1, that's the image that we defined at the top. This is going to be player1.x, player1.y, player1.w, okay, so we have player1x, player1y, player, okay, that looks good. And so I'm just going to copy this because we're going to do the same thing for player 2. And so this is going to be player 2, tank 2, okay, perfect. And so we have this this function, and so I'm just going to call that function, and we're gonna call that using our SetInterval function. And so SetInterval, we're gonna call the function, and then that's it. Okay, so that looks good there. And so I'm just going to go ahead and run that. And what we see here is essentially the start of our game. Okay, so we're drawing the images. Are we getting errors? No errors. So perfect. That's what we want. Okay, so what we want to do now is make controls work. Okay, so let's go ahead, and we basically have controls done in the Keydown and Keyup handler. We just need to map them to properties within our game. Okay, and so here I'm just going to right here under draw image rotated, I'm just going to go ahead and hide that because we don't need it anymore. And I am going to say function okay, then we're just going to say if. So if left press is equal to true, we're going to say player1 rotation minus equals 1. Okay, so we're going to change the rotation by 1. And then so here we can go ahead and copy that. And this is going to say right pressed. And here we're going to say plus equals 1. And then up pressed, what we're going to do, here is we're going to change the location based on the rotation that we have currently. The X and Y are going to change in respect to the rotation. Okay, so what we're going to do here is we're going to say player1.x, and here we're going to say plus equals math.cosine, and then this is going to say player1.rotation, okay. So that basically this is the unit circle, right? So to find an x along the edge of a circle, we would use within a certain amount of units, we would use cosine to find the x, okay? And then to find the y, we would use the sine, okay? And so I'm just going to copy this. Oops. Okay, and so sine gives you the y value along the edge of a circle. Okay, so we're rotating the x, and it is changing, and cosine and sine are finding that for us. Okay, so this takes care of player one. Let's just go ahead and test that out. Not seeing any changes. Oh, so we created this function. We have not called it yet. I'm gonna go ahead and get down here, and right after my clear rect, I'm just going to call my controls. And now when I click that, I should be able to move my tank around. Okay, so we have a pretty good start to things. And so what we want to do now is we want to do the same thing for player two. And so I'm just going to copy this because player two is going to be very similar. Oh wait, we have down pressed as well. So down pressed is we need to be able to back up in case we are trapped. And so here we're just going to say down pressed, and down pressed is going to be the opposite. So instead of plus equals, it's going to be minus equals. Okay. So here, just going to copy this and paste this down below. And instead of 0 pressed, this is going to be A pressed. And this is going to be player 2. This is going to be D pressed. Of course, player 2. This is W pressed. And we have player 2, and this is going to be S pressed. And changing the player 2 as well. Let's go ahead and see what that looks like. We got this player, we got this player. Ooh, something's wrong with this. Okay, so let's look at this. Oh, so player one, and this is in regards to player 2 rotation. Okay, let's just go ahead and double check that. It's always nice to make sure things are working as you code, so you don't have to find the error after you've added 1,000 lines of code. Okay, so this looks good for right now. And so what I want to do now is actually create some firing. And so actually, you know what, before actually firing is probably where we want to go. And so this is fine for controls for right now, but we will be changing this. And so now what we're going to do is we're going to define a bullet, okay? And so right under key up handler, we're just going to say function okay, and so this is going to take in some values. It's going to take in an x, a y, a speed, and a rotation. And then so here, we're just going to say this dot x is equal to x. Okay, and then there's a few other things that we probably want to define. And so time of birth, that's a weird way of saying it. So probably time created or something like that, but we'll just say time of birth. It has been birthed into this world. And we're just going to say current seconds, and we'll define that in just a second, that function. Okay, so current seconds, and then we're going to have the width and height. So this dot w, and we're just going to define it at 3. This dot height, and we're going to define it at 3. And so looking at these properties, width and height, we see that the bullet is actually going to be a rectangle, but it's going to be such a small rectangle, it looks like, it's going to look just fine. We could do circles, but, it adds some a little bit more processing time because of just dealing with circles. So we'll look at that later if we want to change these to circles in another video, but I'm going to get through this whole video in one go. And so here we have, let's see here. So we have our bullet, and so let's go ahead and we need to define a few things, okay? So we're just going to define a function on its own, and we're going to just call it bullets, okay? So we're going to say let bullets, and that's going to be an array, and then we're going to have two functions. Let's see here. Yeah, we'll have two functions because we don't want these bullets firing too fast. Okay, so we're going to say var, or I'm not going to say var. I'm looking at old code and changing it to newer code. Although technically I probably should be using const instead of let here. But yeah, it's all the same. So here we're going to say let canFire equal to true. So this is going to be player 1's firing. And let's see if we've actually, so we are actually handling this here. And so I don't even want to do that. So what we want to do now is we want to we want to do this. We want to come down to our Keydown handler, and this is where we are firing, okay? So what we want to do is we want to add a few more conditions here. So I guess this would be player 2. So we're going to say player 2 dot can fire. So if player 2 can fire and player 2 has not been hit, so player, and so I guess we'll just add this, and so player 2 dot has been hit. Okay, so it hasn't been hit and it can fire. We should let him fire. And I'm just going to go ahead and copy this because we need the same thing for our 0 pressed down here, and this is just going to be player 1. Okay. Okay, so this looks good, and this is all we need to do with our key down handler. So we'll never touch it again, but what we want to do now is go to our controls. Let's see here. Here we go. So what we want to do now is for player 1, player 1 is going to have 0 for its firing button. And so right here, right under down, we're going to say if 0 pressed. Okay, so that looks redundant. So we'll just say if 0 pressed. What we're going to do is we're going to say we're going to get the position of our bullet. So what I mean by that is if we look at the game, okay, and let's say we're just right here. Where does our position start? Okay, where does the position of the bullet start? Well, if we were just to pass in the player 1 X and Y, the bullet would fire from the top left corner of this tank. And so what we want to do is we want to actually get the center of the tank and then add 25 to the math cosine and sine, so that we are actually from center, we are here all the way around. So when it rotates, it will shoot from the end of the turret no matter where it rotates. Okay, so that's what we're going to be doing here, and that's so the math is a little bit more complex than just passing in the X and the Y of the player. And so we'll do that by we'll just say let X equal, and then here we'll just say player 1.x, and then we're going to add the player 1 dot width divided by 2, and then we're going to add 25 times math.cosine player 1 dot rotation times math.pi. So we're just converting it to radians. Whenever you see that math.pi divided by 180, we're converting degrees into radians. Okay, so this looks good, and what we're going to do now is we're going to copy that, paste it below. This is going to be y now, so we're going to say let y, and that's going to stay the same. This is no longer going to be cosine. Y, to find y on a unit circle, we'll use sine, and everything else is the same. Okay, so what we want to do now is we want to add these to our bullets, and so here we're going to say bullets dot push. So we're going to add them to our array, and we're going to add a new bullet. And we're going to pass in our X and our Y. And then, so this, let's see here. So let me see what we need. So a speed and a rotation. So the speed, we'll say the speed is going to be 1/2. And you can feel free to play with that. And actually, yeah, so that's fine. So 1/2. And what we want to do now is say player rotation. Okay, so we're going to do that, and this should say bullets. Okay, so this looks fine for creating that bullet. And so I'm just going to copy this. because it's going to be very similar down here. And so space pressed is going to be, in fact, I'm just going to copy this whole if statement. And so instead of 0, we'll just say space pressed. And this is going to be player 2, 2, 2, 2, 2, 2. And bullets pushed. And we're going to pass in the rotation of the second player so that it shoots at the right angle. Okay, so that's why we have to pass in that. Okay, and so now we have an array filled with bullets, but nothing is really showing us those bullets. Okay, so how can we change that? One thing that we want to do real quick before we move on is we want to change it so that he is already fired, and so we want to reflect that change. And so we're going to say player 1.canFire equal to false. And player 2.canFire is equal to false. Okay, so that looks good. And what we're going to do now is we're going to draw those bullets. Okay. Now, let's see here. Okay, and so what we want to do now is we want to actually draw those bullets. Okay, and so here, right after this controls, we're just going to say function draw bullets. And so here, we're going to loop through those bullets. And so here we're going to say for let I is equal to 0, while I is less than bullets.length I++. And so here we're going to draw it with just a red square. And so here we're going to do fill style and RGB. And let's see here. So red, we'll just say 255 0 0. Okay. And so now what we're going to do is we're going to fill the rect. We're going to do CTX. This is going to be bullets at I.x, bullets at I.y for the individual bullet within our array within this loop. And this is going to be bullets at I.width and bullets at I.height. Okay, perfect. So that just draws the bullet. And now we want to advance that bullet. Since we're drawing it, we already have that all the bullets properties from this loop. We want to go ahead and advance the bullet within the same loop. Okay, and so that's just going to say bullets at I.x, and then we're just going to say plus equals bullets at I.speed times math.cosine bullets at I.rotation Okay, perfect. And so what we're going to do here is we're just going to copy that, paste it below. This is going to be the Y speed. That looks fine. This is going to be sine, and all other things stay the same. So what we want to do now is we want to just do that. That's it. Okay. And so let's go ahead and call this function. And let's just make sure things work. Oops. Okay, so here we're going to go to our console and we'll see unexpected number on line 201. 201 for let I equal 0. Perfect. Okay, I'm getting some errors. So let's see what exactly is going on. Current seconds is not defined. Okay, so let me go ahead and define that for us once I find it. So it should be a pretty simple function, and it is. Okay, so here we're just going to define this function. It's basically telling us the time. And so here we're going to say function current seconds. And here we're going to say let time equal new date. And this is functionality that's within JavaScript. And so here we're just going to say return time divided by 1,000. Okay. And so now let's see what that looks like. Probably getting some errors here. Wow. So let's go and look at some things. So it looks like things are not what we want. And so here we have bullet, XY, speed, rotation. That looks fine. That looks fine. Let's try and see if this is it. So at the time of creation, let's go ahead and look at controls here. Player X, player 1 width divided by 2 plus 25 times math.cosine player 1 rotation times math.pi divided by 180. Okay, that looks fine. Y is player 1 Y plus player 1. Okay, so this is it. So width, this should be height. Okay. And here we have width, and this should be height. Okay. Okay, so did we get any errors there? Because it should continue. Okay, so we're pushing in the new bullet. We got that. And so all this is fine. So let's go down to draw bullets to see if anything there is amiss. So we have Y, X, Y, width, height. X plus equals times math.cosine. Right here. Rotation. Okay. So we see that all the bullets shot out at once. Okay, so and then you know, we weren't able to fire after that point. Okay, so that's actually a good sign. So we know that the bullets work. Now we need to limit the fire rate. Okay, and so one thing that we need to limit the fire rate is so here what we want to do is on the 0 and the space pressed, we're just going to add an extra thing that says player2.canFire. Okay, and the same thing for the 0 pressed up here. Okay, and so this will prevent that barrage from happening, and it does. And so what we want to do now is we want to actually make it so that they can fire again. Okay, and so to do that, we are going to add a stupid little function. It really is. And when I first created this game, I was like, this seems like a good way of doing it. And so that's what I stuck with, and I will stick with the same way, but when we refactor the game later on, if we ever do, we will probably change this. Okay, so here what we want to do is we want to say function reset bullet. Yep. And here we're just going to say player1.canFire. So stupid. Okay, so we have this little function, and what we're going to do here is and I guess we could have just done it right in here. We could have just said right here. But what we're going to do is we're going to say SetInterval. Reset bullet. And so we're just going to save at 500. Okay. So that looks fine. And so here we're going to have another reset bullet 2. Okay, so let's actually see if that does it for us. Okay, perfect. Now there is a slight thing where you can shoot 2 in pretty rapid succession. You know, I'm not really too concerned about that. We just don't want like a spray of bullets coming out. Okay, so that is fine now. So now we're getting to some of the meat of it, and what we want to do now is we want to actually start figuring out collisions. Okay, so actually before we figure out collisions, we need to draw some walls. Okay. And so the first thing is we're going to create a new variable, and for lack of a better word, we'll say walls. Okay, and then we're going to define what a wall is. We'll do it right above bullet since they are very similar. And so here, this is going to take in some variables. It's going to take in an x, a y, a width, and a height. And guess what? We're going to name it just that. So here we're just going to say this dot x is equal to x. This dot y is equal to y. This dot width is equal to width. This dot height is equal to height. In fact, this will being lazy about it, just say W. Okay, and so now we have this wall. What we're going to do is we're going to push in some walls into our array, and I have gone ahead and created a few, and so I'm just going to paste them here to save a little bit of time. And so these are the walls that we're pushing in. So this is going to be the X and Y, the width and height. These are walls that surround the edges, and these are just walls that are going to be in the center of the room. Okay, and feel free to change those arrangements around. You could add more walls, you could take these walls out, you can do whatever you like. I would keep these in just so that you have some boundaries, but otherwise you're fine. Okay, so we have these walls, and so what do we need to do now? You probably guessed it, we need to draw these walls. Okay, so right here, I'm just going to create a function called draw walls. And, oops. So what we want to do now is we want to draw the walls. Okay, so here we're just going to loop through our walls. So we're going to say for let I equal 0 while I is less than walls dot length I plus plus. Okay, and then here we're just going to fill in our wall. So we're going to say ctx.fill rect, and this is going to be walls at A dot x. I'm sorry, this is walls at I, walls at I dot y, at I dot y, walls at I dot width, okay, so that looks great. And so what we want to do is, well, we want to see if our bullet has collided with a wall. Well, let's actually see if this is drawing our walls first. Okay, it draws our walls, but if we fire, whoops, that's something we'll look at later, but it's not a big deal. Just changes the fill style of our thing. So what we want to do here is, first of all, we'll just fix it right now. Inside of this, we're just going to create our fill style right here, ctx.fill style, and this fill style is going to be equal to, and then black is what I like for the wall color, and so that takes care of that. And so what we want to do is we want to make those bullets stop. Now this is another kind of problem in that if we shoot at this wall from this angle, we should be able to have this reflect off this. Now, just seeing that there's a collision is not enough, because if I were down here and I was shooting at the bottom of this, it would collide and it would hit off this bottom in a different way than if it were on this side or on this side or whatever. So we have to figure out, A, is there a collision, and then B, which side of our rectangle did that collision take place? Okay, so that's basically everything that we're going to do right now in this next section. Okay, so what we want to do is we want to loop through our bullets here. Okay, so here we're just going to say for let j equals 0 while j is less than bullets dot length j plus plus. Okay, and then here we're going to have a function that's going to, or an if statement that is going to say, well, are they colliding? So here we're going to say let bullets, if bullets at j dot x is greater than or equal to walls at I dot x, and bullets at j dot x plus bullets at j dot width is less than or equal to walls at I dot x plus walls at I dot width. Okay. And so I'm just going to copy this because the next part is pretty similar. I'm just going to take this part off. In fact, that really should be where it is. And so this part we need to change. So this is going to be our y. And this is going to be height. And this is going to be height as well. Okay, so that takes care of that. And so what we want to do is basically we are figuring out the halfway point, or the distance between centers, okay, to see which side it is going to be on. And so I took this code from somewhere, and again, I don't know where I got it from. But these things, when you're first starting out, these are things that you may not know exactly how to do. And so you go and you search Stack Overflow, or you just go to Google and whatever. And so, you know, these are problems that beginning game devs have, and they overcome it by looking at knowledge sources. And so, you know, if you use code, you generally want to cite that source. But sometimes, you know, you used it so long ago and things have changed. You know, you used it from game to game, and you no longer know exactly where you got it. Okay, so half bullets at j dot w divided by 2. So this is the half the width. Okay, and so here we're going to say let var let I don't know why I said equal there. Let bullet half h equal bullets at j dot height divided by 2. Okay, and so now we're going to get the center of the center x and the center y. And so here we're just going to say let. In fact, I'm just going to, since we're getting kind of low on time, I'm going to copy this over since it's so straightforward. Okay, and so here we're getting the center of x and center y. So this is the center of the rectangle, and this is the center of this rectangle. They're both rectangles. And so we're going to calculate the distance. I'm sorry, the distance between centers. And so we're gonna say let okay, and then let diff y okay, so now we're going to calculate the minimum distance. And so here we're going to say let okay. And so what we want to do is the depth of collision for the x and the y axis. And so this is going to help us determine which side it is going to be hitting, okay? And so here we're going to say let depth x is equal to diff x greater than 0, otherwise min x dist minus diff x okay. And so this is going to be very similar to the y. All right. And so now we're going to check, we're going to check to see if there was like where the collision is actually happening, okay? And so here, this is going to be an if statement that says if depth x is not equal to 0, we're going to get the absolute values of our x and y's, and we're going to compare them. So here we're just going to say if okay, and then what we're going to do is we're going to see if it's the left side or the right side, okay? And so that is just going to be an if statement that says, well, so here we have this if statement. We're going to have an else down here. Okay, so inside this if statement, we're going to have another if statement that says, well, if the depth x is greater than 0, then this is going to be a right side collision. The thing is the rotation is the same, so we don't even have to go into if it's left or right side, because it'll act the same for left or right side, but it does not act the same for the other. And so here, what we're going to do is we're just going to say, well, we're going to say bullets at J and then that's J. Oh, looks like I have lost my mind. So these up here are J as well. I'm sure you picked that up. You're like, what is he talking about? If you see, it is 1:16 a.m. So I should probably be in bed, and this is walls at I. I'm going to be filling this tomorrow. In fact, I may go ahead and pause it here in a second and finish this up tomorrow night. Okay, so we have this, and now what we want to do over here and this is going to be 360. Okay. So this is collision on the X. This is collision with the Y, bottom and top. And that looks to be good code. Okay, and so I'm just going to go ahead and do that. Okay, perfect. And so the next thing we're going to do is we're going to be looking at actual collision code. So that's what we're going to be doing next. The first thing is we're going to need like a point. Okay, so because what we're going to do is we're going to be dealing with polygons. And so you can extrapolate this out to as many different sides as you want, but what we're going to do is just be dealing with 4 sides, okay? So for rectangles and squares. But you could build this out as long as it is a convex structure. This code will work for your projects, okay? So the first thing we're going to do is we're going to create a function, and we're going to call it xy. Okay, so xy, this is going to be a point. It's going to take an x and a y. Oops. An x and a y. And we're just going to say this dot x is equal to x. This dot y is equal to y. Okay, that's fine there. And then we're going to create another function called a polygon. So this is going to take in a set of vertices and edges. Okay. And so here we're just going to say and these will be arrays that are being passed in. So whenever you see like it ending in S, you can pretty much guarantee that it's going to be some kind of array. Okay, and so so that looks fine. So we have a polygon, we have an XY, and yeah. And so let's go ahead and look at the actual will collide. Okay, so here we'll have will collide, and so we're going to create a function, and it doesn't really matter where you're creating this at, but we'll create it here, and we'll say function So you can kind of guess what kind of result you're going to return from this function. And inside this will collide, we're going to have two things that we're passing in, two parameters, box 1 and box 2. And basically we're just seeing if box 1 and box 2 are colliding. Okay, pretty simple. Everything that we have within our game are boxes, and so you might, if you were to, like for instance, extrapolate it out and make it so that it's different polygons, you might want to say polygon 1 and polygon 2. Okay, and we can generalize that right here and right now, but I'm just going to stick with the name that I currently have. Okay, so this is a big one, and so what we're going to do is we're going to define some points within our box, okay, so that we can start to create this polygon, okay? And so our box is going to be, so we're going to start kind of like axis aligned, and then we're going to have our degrees of turn, so however much the box has turned, and then we're going to go ahead and create the points for that that turned or non-axis aligned box, okay? And so that's kind of what we're doing here. And so here we're going to this site is now kind of defunct, but I'm just going to go ahead and put it on there anyways. So right here, this is code from a few years ago, and so a few years ago I was able to go to this site, and they had this they had some pseudocode. At least I think it was pseudocode, and I went ahead and took it and adapted it to this current game, okay? And so here we're just going to go ahead and put that in. And so here are the let's see here. Okay, so what I'm going to be doing is I'm going to take the code and kind of paste it in and explain it, and you can pause the video and type it out as you wish. And so here what we're going to do is we're going to get the initial conditions of the polygon. And so here I know this is the naming convention is kind of off, but that's only because we actually have another set of points that use the P1, Q1, and it's just lowercase b, and it seems it is a little bit confusing, but so we probably should have named this starting point, and then the next point it would be modified point or something like that to modify it to this degree, okay? And so here we're just getting the points of the within the rectangle, and so here this is the center of the as far as the center of the x values, center of the y values, and so these are just different points. And we're going to go ahead and put them together. Now, what you see here is a lot of these actually share the same values. For instance, this and this, but we're going to use these and transform them later when we go ahead and turn them into their non-axis aligned values. Okay, and so that's what this is going to do right here. Okay. So we're getting the points as if they were rotated, okay? So if you were to think about it in terms of the game, this is the axis-aligned version of the tank, and we found the points around the edges. and then this is the tank with the rotation added in. And so this is what we're trying to figure out, what these points are, so that our collision code can actually function properly. Okay, and so that's what we're doing here. And this is very similar. We're just using the unit circle to figure out these points. Okay, and so just using the unit circle. Remember, cosine figures out x, sine figures out y, and we're just figuring them out based on that formula. So this is the point for these are the points for the first box, and then here's going to be the points for the second box. Actually, this is going to be, I believe, box 2. Okay, it even says it right here, box 2. And why I did it like that, I don't know. This is going to be box 1. It's the same code, except this one has a 0 rotation because we're dealing with in fact, I probably should go ahead and give the walls a rotation of 0 since they aren't rotated, so that this can be generalized, so that when we do, and we'll do that later, okay? We'll keep it as is right now, but we'll change it so that box 2 has its own rotation, so this is not a hard-coded value. Okay, so we figured out the points for the 2 boxes, and what we want to do is maybe we want to test to see if these points are actually the right points. Okay, because if we pass these points, created some vertices and edges based on these points, how do we know that they're correct? Okay, so one way that we could figure out if they're correct is we could actually run this code and to see if it actually surrounds the tank as we go around it. Okay, and so we're going to do that. And so box 1 is the tank. And so I'm just going to, oops, I actually need to run will collide. And so this is going to be inside of, let's see here. We could just do it here. Because we really care about box 2. So box 1 can just be walls at 0 at this point. And this could be tank 1. Okay? And so we're just going to test it using that right there. So here, well, maybe something else. So we have our box. We have our there's no errors showing up, so I'm not quite sure where the issue is. Oh, so this is tank 1. We don't actually have a tank 1. We have a player 1. Tank 1 is the name of the actual image. And so, still, and still. Huh. Well. Oh. This is the issue right here. Sometimes it just takes a second. I mean, I know some of y'all are learning out there. and you know, even seasoned programmers have issues from time to time. And so if you see this in your code, you can clearly see it, but there is a red box defining the points that we just used. And so that's what those new points are creating, is this box that it now moves around with the rotation. Okay. And so yeah, that's all we're doing there. I'm just going to go ahead and delete that. We don't need that. And I'm going to delete this. I don't need that anymore. So one thing that we need to do is create the polygons for the these points. Okay. So I know this is a lot, but this is just what I added. And so we're going to create the vertices, and then we're going to create the edges. Okay. And so if you want to look at you know, 3D graphics and polygons and stuff like that, you could read up a little bit on that. But here all we're doing is creating the vertices, which are the points of the polygon, and these edges are the lines that connect the point. Okay. So that's basically it. So here we have vertices, edges for box 1, box 2, and box 1. Okay, and then we create these new polygons, and so we call it polygon A and polygon B. And then we need a function that just checks the collision between polygon and A and B. Okay, and we're going to do that by determining if lines overlap. Okay, and so essentially what we're doing here is we are going to be using those two polygons to say, well, hey, is there a line that we can draw in between them? Okay, in between the two polygons, and if the two polygons, if we're able to draw that line between the two without either of them touching the line, then they don't collide. But if they do touch the line, then we know that they collide. Okay, and so that's essentially what we're doing here. All right. And so for this site, this is gamedevelopment.tutsplus.com. You can look at a lot of the math that goes between it all, and they use you know, their math is a little bit different, but it all works the same. So you know, you can choose whatever you like. Since this is no longer defunct, you could definitely come back and look at exactly how it all works and go through the code yourself. So what we want to do is we want to define a function that does that for us. Okay, so that's going to be the separating axis theorem, and we're just going to call that SAT. Okay, so here we're just going to create a function or an if statement that says, well, if this function given polygon A and B, we can say that, well, there is either a collision or there isn't. Okay. So that's that. All right. And but now we need to create this function, because we said, hey, if there's a collision, that's fine. But how do we know if there's a collision? Okay. So let's see here. Okay, so we're going to just go ahead and create this this SAT function. Let's see here. So we know that it's going to take in 2 polygons. And so we're just going to say a function sat polygon A, polygon B, oops, B. All right. And so what we want to do here is we're basically testing that line, okay? And so I'm just going to go ahead and here I'm just going to go ahead and give you the code for this, and you can go ahead and write it out, and we'll kind of talk about the what is going on here. But one second. Okay, and so this is basically the code. We'll kind of talk through it. Now this is I did make some adjustments to code that I saw. Whether it was pseudocode or not, I don't quite remember. But basically, we're creating a perpendicular stack of lines. So a stack of perpendicular lines for polygon A and polygon B. And then we have these A min and max values and B min and max, and they start off as null. And then we come down here and we look through this perpendicular stack, and we compare it to the vertices of each of the polygons, okay? And we create this dot product value, which you're gonna have to dig into the details of this to figure out exactly what this dot product value is giving you. But basically, if this dot product is greater than A max, or if A max is null, we're going to set it to A max. Okay, and we're going to keep on going through this, and if A min is equal to null, or the dot product is less than A min, we're going to keep on going through this until we've gone through all the vertices. Same thing for polygon B, and then when we get down to it, this is what's going to determine if there is a collision. So if there is a collision if the A min value is less than the B max, and the A min value is greater than the B min, or the B min is less than A max and the B min is greater than the A min value. Okay, and so this is going to determine that there is a collision. So instead of continue, we probably could just say return true. In fact, I'll just go ahead and change that. Okay. And so so that is basically it. If these conditions are not, the else statement says, well, there was no collision because there was a line that could separate these 2 polygons. Okay, and so I'll just go ahead and you can go ahead and pause this to get this down real quick, and then pause it again to get the second half of that function, since it's a very long function. Okay, and so what we really want to look at now, get rid of that, is we want to say, well, let's actually use this function, okay? So it is being used, but what we want to do is actually use the will collide box. Okay, so will collide function. So where do we actually use that? So inside of controls, this will collide is actually what's going to help us determine if we can move into a particular direction. Okay, and so so here, if we go to controls, right here, we should be determining, we shouldn't just be blindly adding to the player X and Y. What we should be determining is, can we actually move there before we actually apply those values? Okay, And so what we're going to do is create like a ghost player that moves to that value first, and we're going to see if there was a collision, and if there was, then we will just say, let's not move there. Okay, the ghost value, the ghost player just kind of like ceases to exist, and we go about our game. But if there is not a collision, then we apply those to our player. Okay, and so let's look at what that code looks like. And I'm getting kind of lazy. The video is getting kind of long, so we are just going to just pump it out real quick. Okay, so for up pressed, we're going to create that ghost player using the updated values. So this would be player 1. Essentially, these values are the same thing. So we're taking our current x and applying this value we want to move to, and our y and applying that value we want to move to, and we're going to pass it into a function or a for loop that's going to compare it to all the walls, and if it collides with any of the walls, then we're going to set is collision equal to true. All right, and basically we're going to say, well, if there's a collision, we don't want to do this, but if there is no collision, then we'll go ahead and move this. All right. And basically these are the same, so I'm just going to copy this and put this here. And the pluses change to minuses, just like before. And this will be minus equals. And okay, so essentially we're just changing the plus to a minus, and this is for player 1. Okay, and so, but we need to do the same thing for player 2. So that's going to be W press down here. And so basically it's the same thing, player 2. I'm just going to copy and paste and change them real quick. So that's just copied, pasted, and then changed from player 1 to player 2. So for the W pressed. And so this is the same thing. And then same thing for the S pressed. All we need to do is change those pluses to minuses. And now we should be colliding with walls, and it should stop us. So we're just going to go ahead and check that. You can go ahead and pause this video, make sure that your code is like mine. But let's go ahead and test that. Uh-oh. Let's see here. I got some problems. Polygon B is not defined. So where is polygon B? Let me go ahead and go back to that. That's going to be 440. Okay, let's check that. That's why. Okay, so well, we're still there. So do we have another polygon B issue? Cannot read properties of undefined length 457. Dot edge dot length. Okay, so these should be edges. Yeah. Okay, so polygon edges, 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 and then down here, the vertex should actually be vertices. And vertices. Okay, so you may want to check this. So right here we changed edge to edges, edge to edges, 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 and then down here we have our vertices. So one vertex would be a vertices at J, okay? And that's why we call this vertices, because it is a list of like multiple vertexes. So vertices, 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 and that should actually get us going in the right direction. Well, we're getting close. Getting close. XY is not defined, and 459. 459. Oh. So this is an XY. And that should do it. And if not, the errors will keep coming, and we'll eventually get there. You know, I'm kind of changing the code on the fly. So this is going to be 473. So 473, we have polygon vertices, and then here we have polygon vertices. All right, I'm pretty optimistic. Okay, we got no errors. Okay, so just a stupid mistake. So right here, I tried to optimize it, but I forgot that we're actually inside of this loop, and we need to loop through it completely. And so we just can't return true if this is the case. So we just continue. And this will return false otherwise, okay? And so here outside of it is where we're going to return true. So go ahead and make that change. You should be looking at the bottom of the sat function, and so make sure that yours matches mine 100%. Okay, so with that code, then we have this, okay? And so now you can't drive into the walls, and that's perfect, okay? Now sometimes you can get stuck on some corners, especially if you start turning into the corners. But in that case, you just have to, you know, turn enough so that you clear the corner, and then you could keep on going. Okay, so what do we need to do now? Well, the clear thing that we need to do is this bullet. It's not exactly hitting, and so we want to change that. So how do we do that? Well, we are going to use this will collide, okay? And so we'll probably go ahead and use that inside of draw bullets. And so let's go ahead and go to draw bullets. And right now we're just drawing the bullets, okay? But what we want to do within draw bullets is have some if statements, okay? So probably right here, we're going to see if they actually collide, okay? So here, now we also want to see if they're colliding with the edges. And so let's see here. Let's go to draw walls real quick. Maybe that's where we probably want to put in let's go to draw walls. we'll come back to draw bullets, but we want these to bounce off the wall. And do we currently do that? Well, we do right here. Oh wait, we already have that in the code. So all we really care about is not this. We care about the bullet, and so inside of draw bullets, we care about if it is colliding with other tanks at this point. And so here, right here, we're just going to have an if statement. If will collide. We're going to pass in player 1 with any bullets. So we're just going to bullets at I. And player 1 has not been hit. So if these are true, we want to do something here. We want to first we want to probably splice the bullets. So we'll say bullets at I dot splice, and then we're going to go from so now this would just be bullets because we're just doing the array, and this is going to say I to 1. We are going to increase player 2's score. We are going to say player hit time is equal to current seconds, and I'll get to that in a sec. So player hit time, basically this is going to help us reset the match. So if a certain amount of time has passed and a player has been hit, then we want to reset the game so that it doesn't just stall out and it's a one-hit affair. Current seconds. And then we're going to say player 1 dot has been hit is equal to true. Okay, so same thing here. We're going to copy this, and this is just going to be an else if. And this we're going to pass in player 2 here. Player 2. And this is going to be player 1's score. So if player 2 has been hit, we're going to increase the score of player 1. And we're going to say player 2 has been hit. And then here, we're going to say, well, this is going to be an else if statement that says, well, if current seconds is less than bullets at I dot time of birth is greater than 7. Okay, so 7 seconds have passed, and or more, and so what we want to do is get rid of the bullets. So this is going to ensure that there's not a billion bullets just bouncing around. Okay. And so that should take care of that. Let's go ahead and make sure that that is happening. Okay, it gets rid of it and gets rid of that. And so now we have collision working. But what we want to do now is, make that really cool explosion happen. Okay. And so how we're going to do that is, so this is, I'm not really proud of this code, but it works. So what we're going to do is we're going to come up here and we're going to add all the explosions as images. And now this was me like 4 years ago or something like that. Okay. And so I have included all these tiles for you. So starting with the first, and that's why it's such a smooth animation, from a sprite animation, because it has so many frames. Okay, And so here we have 16 frames for this animation, and they are going to start at 1 for tile 0, 0, 0 and end at explosion 16 for tile 0, 1, 5. Okay, so now that we have all these, we're going to create an array and what we're going to do is we're going to whenever we have one thing that we need to do is since we're creating an array of animations, we need an actual animation. Okay, so basically an animation is going to be kind of like function XY or function polygon. It's basically just going to be like a data type. Okay, so this is going to be function or a class that we can create multiple animations from. So here, animations, and it's going to take in a type, an X, and a Y. Now I initially put type there because I was going to have different animations for different things. And I still may, but right now the only animation that's in there is the explosion. But here we're just going to say this dot type is equal to type, this dot x is equal to x, this dot y is equal to y. And then we're going to create some other types of values that are not passed in as parameters, and maybe they should when we add extra animations. But here we're just going to say this dot stop it is equal to 16. So this is the iteration that we're going to stop the animation on, and this dot start it is equal to 0, and this dot animation delay is equal to 0. And so when we start to implement these things, this stuff will start to make sense. And so what we're going to do is we're going to create a function called draw animations. Okay, and so inside our draw animations, it's equally as ugly as initializing all those variables for the different images. So equally as ugly. And so it basically is a for loop that iterates over every frame that it could be. And so I'm just going to copy this code in because it's nothing glamorous and it would just be completely boring. So basically, if the animation type, so we're going to loop over all the animations, and if that current animation, if its type is equal to 1, we're going to go over its iteration. If it's on like the 15th iteration, then we're going to draw this image, okay, explosion 16, which we have defined up at the top. And then this is where we use our animation delay, and so this is going to increase until the animation delay is equal to 8. At that time, we're going to increase our start iteration, and we're going to set animation delay back to 0. And I guess we should say greater than or equal to. And then if animation is greater than or equal to 16, we're going to get rid of the animation. Okay, so I encourage you to go ahead and pause this. Make sure that you have all the code here, and it's essentially the same all the way down. So there's much better ways of doing this, but I have not refactored this code since I looked at it like however many years ago. So what we're going to do now is we have this way of drawing animations. Now we just need to add animations into our game. So whenever something cool happens, we need an animation to happen. And that's going to be inside of draw bullets. So inside draw bullets, like right here, okay, we're going to push that animation. We're going to say animations dot push, and we're going to push in a new animation here. And this new animation is going to be of type 1. It's going to be bullets at I dot X minus bullets minus player 2 dot W, and this is going to be bullets at I dot Y, and just the minus there is there to kind of center out the explosion. Okay, so this is player 2 dot H, and so that'll just center out that explosion. And so I'm just going to copy this. All right, and so this is going to be player 1 width and height. All right, so let's look at that. Let's see what that does. Uh-oh. That glitch in the matrix means that there is an error. Failed to construct animation. Parameter 1 is not of type animation effect. Okay, so let's look at that. Here we have one new animation. So we have bullets at I dot Y. Let's go see where we define this animation at. I'll explain some things. Oh, there we go. It just had an S on it. So let's go ahead and change that. And so it should be function animation and not animations. There might be another error here. Oh, whoa. So one thing that we have not, so make sure that this is changed. And we are not calling this draw animations, and so that's super important. We're going to go ahead and if it's not in our draw function, it's not happening. So I'm just going to go ahead and call this function, okay? Okay, the centering could be a whole lot better. Not quite sure. I think what's going on is I have something a little bit mismatched here. And so I think this should be this doesn't exactly minus, that doesn't quite make sense. So what we should probably do is kind of center it into the middle of the player. And so let's just say player 2.x, and this is going to be plus player 2w divided by 2. I'm just going to copy this. And what we're going to do here is just paste this over here. This is going to be y. This is going to be height. And I'm going to copy this again. And we're going to change this to player 1. All right, so let's see if that actually looks a little bit better. What have we done? Player 2. So this should be, this is checking to see if player 1 has been colliding. So this should be player 1. This should be player 2. And I'm sure y'all caught that because y'all are super smart. So let's see here. Whoa, that is not cool. Player width divided by 2. Player height divided by 2. But it is axis aligned. So that's the part that that's the part that sucks. It's non-axis aligned. So this is going to give us some kind of weird results. So we'll just say player X and player Y. And we're not going to add that onto it. And so let's see what this looks like. Close enough. We could actually do a whole lot better in that we could actually pull in. So for instance, in will collide, we actually get the real x's, the real edges of the rectangle that has been rotated, and so we can start to pull out some of these values and take the center point from either of the two edges. So say for instance, point 1 and point 3. That's going to be the center. So the middle of this line between these 2 points is going to be the center of the rectangle here. And so we could start to use that point as the center of our. In fact, we could store that point inside of the player every time that this gets calculated, because it's being calculated anyways. We could just store it in the player and then pass that on to, like, have it stored as a value as like explosion point or whatever, and then you could just pull that out and say, well, this is this is what we're going to use. But here we'll just do this for right now, but we'll come back to that because I think that is something worth exploring. As long as you have an idea, right? As long as you have an idea as to what you should do, then you have avenues of exploration, and you can improve upon what you have. So we have ideas. So the next thing we're going to do is we're going to create that sound, because the explosion's happening. We want the sound to happen. And so here we're just going to create a function called play sound or something like that. And so let me go ahead and pull that up. And so play sound, if you've had me for any other tutorials, my play sound is always the same, and it's this code right here. So we call this function. We pass it in the source of the file location, and it creates a new audio. It sets the source to the parameter being passed, and then we play that file. Okay, nothing's changed here. All we gotta do is pass in the source. Okay, and I've included the file for you. And so what we're gonna do here is inside of draw bullets, we're going to go back down there. After we play the animation, after we add the animation, we're going to play that sound. We're going to say play sound, and this is going to be explosion.mp3. And I'm going to copy that. We'll paste it there, and let's actually see if this is gonna turn up my audio a bit. Okay, so that is a big sound. I like that sound. I got that off of freesound.org, so you can feel free to change that sound if you like. For me, it sounds nice. There's not a lot of glass, and you hear some glass on that explosion, but there's not a lot of glass inside tanks, so you may want to change that. But I feel fine with that. One thing that we probably want to do is make a sound for firing. Okay, and so I definitely want to do that, and so that's going to be inside of our controls. So let's go to controls here. And that's going to be right here. So if we can fire, what we want to do is we want to fire and also play this sound. So play sound, and this is going to be fire.flack. And I'm going to go ahead and copy this. And down here, same thing for space pressed. We're going to play that sound. And so let's just go into... All right. One thing that I see that we're missing is our score. So we'll just go ahead and draw that real quick. Very easy. Not much to this function. Okay. And so here, it doesn't matter where. We're just going to, right under here, we're going to say function draw score. And so it's basically setting a fill style and a font, and then just two little fill texts. Okay, so we set our fill style to black. We change our font. You can change it to whatever you like. And I say player 1 score is this, and this is where we're going to draw that. Player 2 score is this, and this is where we're going to draw that. And then we're going to take this and we're going to say, well, I want it to be inside my draw function, so it draws every time. And we're going to come up here, and now we have our player 1 score. Perfect. And so something else that we need to do now is we need to create a reset game type of function. Okay. And so let's go ahead and do that real quick. So I'll just do it right here. Function reset game. Okay, so what we want to do is reset the game if player 1, so I'm just going to go ahead and set that. So if player 1 dot has been hit, or player 2 dot has been hit, and if current seconds minus player hit time is greater than 4, so 4 seconds have passed since the player has been hit, what we're going to do is we're going to create some random spots for our players, and I'm just going to post this up there. So we got these random spots for our players, and we actually just set the values. But this isn't it, because this random spot could land you on a wall or something like that, and we don't want the player to land on a wall because they wouldn't be able to move and they would just be shot. So what we want to do is we want to create a while loop. Okay, and so this while loop is going to say if we collide with any boxes. So if player 1 collides with any box within walls, or player 2 is colliding with any boxes inside of walls. And so basically we're just looping through walls, and I created another method that basically just loops through the walls and returns that value. So if there is any collision with walls for player 1 or player 2, then we essentially want to go ahead and create some more random values to determine if there's a collision. And we'll keep on doing that until there is no collision. And at that time, reset game will be complete. So let's go ahead and get to will collide with boxes. Okay, so for will collide with boxes, it's essentially the same thing as will collide. And so let me go ahead and pull. Let's go ahead and get that. Okay, it's a very, very short function. So here we'll just say function will collide with boxes, and this is an array of boxes, and so it's going to take in a single box and an array of boxes. Okay, the single box is going to be called box 1, and the array is going to be called boxes. Okay, and so basically what we're going to do is we're going to set a Boolean value that says, has anything collided yet? And then here we're going to say, there's a better way of doing this, so we don't loop through every box. But there's never going to be more than a few boxes, so this is fine. But basically, what we should do is just return true here. In fact, we can go ahead and do that. Return true. And then down here, we can just return false if it gets to this point. Okay, so that's pretty easy. And so let's go ahead and test this out. One, two, three, four. Well, I know what we've done. So this is going to be called reset game. And we need to go ahead and put in reset game into our draw function. Okay, so let's go down here. And notice how there was a momentary second where one of the players was down here. Let's go ahead and look at that one more time. If you're fast, you can see sometimes there is, sometimes there isn't, but it keeps on resetting the game, and so you can keep on playing. Now, this is going to be the end of this particular tutorial. And what we would like to do in the future with this is to actually create a server so that we can host this on the internet, okay? And we could have maybe multiple players within our game, and maybe have a larger screen that kind of moves with the player. But we have a lot of the code that we would need on the server side already in the client. And so we'll talk about server client model when it comes to online games, and you know, what the implications are of. Oh, that's the bell. It's time to go. No, it just means someone's at the door. So what we need to, dear Lord, kids are excited. So what we need to do now is, so this is going to be the end of this tutorial, and soon I'll come back in and we will create a server um, where we basically open up a connection with every client that connects, and we can have like a lobby. And so you can connect with a particular map that might be active. You could create maps and then join in that map and then play until you could have like a metric where you have like kills per death or something like that. And so you keep on playing. I don't know really how FPSs work or anything like that, but you could essentially have something like that run through your server that you could host on your own computer, or if you wanted to, you could put it in like a Docker file or whatever, and host it through AWS or whatever, if you really want to spend a lot of money on something like this. But when you do stuff like that, what happens is you start to learn all these other skills that you could start to apply with game development or any kind of IT or computer science related job. And these are the things that you could start to talk about in the interviews. I did this project and I created this web server or this server for the game, and it handled all the truth of the game, and it could scale up to 500 users. Okay, and you could talk about that, and that would be great. And maybe you're just doing this for a hobby. Okay, and if that's the case, well, you have an extra set of tools when you start building multiplayer games. I mean, static one-player games are great, but they lose their fun very quickly when you can't communicate with other people or show how good you are to other people, or just interact with other people. That's what makes games really fun to me. And so this in itself, even if this were like some kind of AI that changed its ability rating every game, and it was something new and interesting, this kind of game would not really appeal to me, even though it's well done because I did it. It wouldn't appeal to me because I wouldn't be able to interact with someone else. That's what makes a game great. And so that's where we're going to go with this game. We're going to create a server that does that for us. Okay? And so that's all we have for today. And I'm looking forward to that video. And if you're looking forward to something like that, go ahead and like and subscribe to this channel, and maybe like this video, and we'll get that going pretty soon. Thank you and goodbye.